By the force of the pregnancy of Diti, the light of the sun and moon was impaired in all the planets, and the demigods of various planets, being disturbed by that force, asked the creator of the universe, Brahma, what is this expansion of darkness in all directions? Report by Srila Prabhupada. It appears from this verse of Srimad Bhagavatam that the sun is the source of light for all the planets in the universe. The modern scientific theory, which states that there are many suns in each universe, is not supported by this verse. It is understood that in each universe there is only one sun which applies light to all the planets. In the Bhagavad Gita, the moon is also stated to be one of the stars. There are many stars, and when we see them glittering at night, we can understand that they are reflectors of light. Just as moonlight is a reflection of sunlight, other planets also reflect sunlight, and there are many other planets which cannot be seen by our naked eyes. The demoniac influence of the suns in the womb of Diti expanded darkness throughout the universe. So, you can guess why I was asked to give class on this verse, since it deals with some astronomical issues. As for the verse itself, it is stated that the pregnancy of Diti was causing darkness within the universe. One might wonder how that would work. I can only say that Diti was a demigoddess and the wife of the Prajapati, Kashyapa, so that presumably she had considerable potency and was linked in with the universe in some fundamental way. However, we don't know in detail exactly how that would work. But Srila Prabhupada goes on in the purport to make a number of comments about astronomy, and I thought I would read a letter from Srila Prabhupada to Sri Damodar Maharaj back in 1975, which also sheds some additional light on this question of the stars, which Srila Prabhupada mentions here in the purport. So, in the letter, Srila Prabhupada says, from the Srimad Bhagavatam, we learn that the universe is like a tree with the roots being upwards. The pole star, which is situated within the asking question star constellation, is the root. The universe is pivoting around the pole star. That is one movement. The second movement is that the sun is revolving around the universe as if it were going around the tree. That is the second movement. The sun is not fixed. If this is proved, then their whole scientific theory collapses. According to them, the stars are all suns. The stars may have the same composition as the sun, but they are not suns. The Brahma Samhita says that the sun is the king with unlimited light and temperature. The Srimad Bhagavatam, sublime literature, describes all these things, and it was written 5,000 years ago. And they say that 5,000 years ago there was no civilization. That Srimad Bhagavatam has this information, or rather, that Srimad Bhagavatam has this information, proves that Indian civilization is the oldest civilization. So, this is a number of interesting points are made in this letter. The last point that Srila Prabhupada makes is that the fact that there is astronomical knowledge in the Srimad Bhagavatam shows that Indian civilization is the oldest civilization. That was the basic point that Srila Prabhupada was making. Yet today, when we look at the description of astronomy in the Srimad Bhagavatam, we tend to think that this does not actually convey scientific knowledge. In fact, it looks quite impossible. It looks as though this is something that is mythological, not in agreement with observable reality. But actually it turns out that one can see evidence in the Srimad Bhagavatam of advanced astronomical knowledge. And in fact, this point that Śrīla Prabhupāda is making can be made on a scientific platform. In fact, recently I ran across some interesting information which is relevant to this issue. What I discovered was that the structure of Bhumandala, as described in the Bhagavatam, in the 5th canto, turns out to be a very excellent map of the solar system as described in modern astronomy. This is actually an interesting point. I hadn't noticed this before, but it can be worked out in mathematical detail. If you examine the orbits of the planets as given in modern astronomy, you find that they correlate in a very precise way with the system of dvipas and oceans described in the Srimad Bhagavatam. It is interesting that that part of the Bhagavatam gives numerical measurements for all of the different features. And these numerical measurements can be compared with the corresponding measurements reported by modern astronomy. And everything lines up very nicely. You can show also that this is not likely to be a mere coincidence, but in fact, it indicates that whoever wrote the Bhagavatam long ago, whenever they did it, had some actual scientific knowledge of the orbits of the planets. Now, this is actually an observation that astronomers should not object to, because in fact what we observe here is that the structure of the dvipas in Bhumandala matches up very nicely with the findings of modern astronomy. So there's nothing there that would cause any disagreement with the modern astronomers. Now, of course, the Indologists are perhaps less likely to be favorably impressed with this, because Indology is committed to the position that old Sanskrit texts are basically pre-scientific and mythological. But these findings show that actually there was advanced knowledge in the old texts. So this fits in with the point that Śrīla Prabhupāda is making here, namely that the Srimad Bhagavatam, in fact, is giving us real knowledge about astronomy, and this shows that, or proves that Indian civilization is the oldest civilization. Now, the historical element here is quite interesting. The information that modern astronomers have about the orbits of the planets was obtained fairly recently. For example, you can take the distance from the Earth to the Sun, which is about 93 million miles, according to modern astronomy. If you look at the history of the subject, you'll see that that was really only pinned down in the 19th century. By the time you come to the middle of the 19th century, astronomers were giving figures of about 93, 92, maybe 95 million miles for the distance from the Earth to the Sun. If you go back to the 18th century, you'll find that the first accurate determinations of the Earth-Sun distance were made, and they got a figure of about 78 million miles. That was the first time it was done with any accuracy. If you go back another 100 years, let's say 17th century, you'll find, for example, a famous astronomer named Johannes Kepler said, well, the Sun must be at least 14 million miles away from the Earth. So back then the figure was 14 million, which is a far cry from 93 million miles. And before the time of Kepler, for a period of well over 1,000 years, the system of astronomy that was followed was that of Claudius Ptolemy, who was a famous astronomer in the Roman period, about 2nd century AD. And he gave the Earth-Sun distances about 8 million miles, which is less than a tenth of what astronomers now say is the right distance. Well, one thing that you can observe in the Bhagavatam right away is that it gives an Earth-Sun distance which is in the right ballpark. The Bhagavatam measures distances in yojanas, and Śrīla Prabhupada uses 8 miles as the length of the yojana in the Bhagavatam. And you can see, if you look at the dimensions of the dvipas and so forth, and the description of the sun and its orbit in the Bhagavatam, that you get roughly the right result for the distance from the Earth to the sun. But the problem there is that the yojana is not very carefully or very precisely defined. And if you look in different sources, you find different values for the yojana. For example, it's defined in one place that the yojana is 8,000 times the height of a man. So, of course, that gives you considerable variation because people have many different heights. Or a yojana is so and so many hastas, or hasta is the distance from your elbow to your fingertips. And that, of course, also varies quite a bit. Astronomers in India had also different figures for the length of the yojana. You can find different texts that say this. So that value is not very well pinned down. But it turns out that if you look at the orbits of the various planets, Mercury, Venus, Mars, Jupiter, and Saturn, you'll find that for one particular value of the yojana, everything lines up very nicely. The sun lines up all of the other orbits of the planets line up in a very exact way with the system of the dvipas. So, and that turns out to be about 8.5 miles per yojana. So, what you have is that at that value for the length of the yojana, which is quite close to 8, which is one of the standard figures that you will find, you see that the orbits line up with what the 5th canto is saying in a very nice way. And this is knowledge that was discovered within the framework of modern astronomy really only in the 19th century. So it's very recent. So how could that have been known at the time when the Bhagavatam was composed? Now, the modern-day scholars don't agree with this idea that the Bhagavatam is 5,000 years old. They will say the Bhagavatam is about 1,000 years old. This is their version. But if you go back 1,000 years ago, who had this kind of astronomical knowledge? Certainly according to established scientific findings and historical accounts, nobody knew such things 1,000 years ago, either in India or anywhere else in the world. So when could people have acquired such knowledge? It would have had to have been in a much earlier phase of civilization, of which we have very few records. That is the only possibility if these agreements with modern astronomy are more than just coincidental. So this is a case that can be made, and it can also be backed up with additional information. For example, in another text involving astronomy called the Surya Siddhanta, you can find information on the diameters of the planets. And this is also a very interesting thing. It's not easy to measure the diameters of planets. It's easy to see the planets in the sky at night. For example, Venus lately has been visible in the evening. It's very bright. But how would you measure the diameter, say, of Venus? Basically, if you look at it, you can't even see that it's a disk with the naked eye. You just see a blob of light. The measurement of the diameters of the planets in modern astronomy also was only worked out recently. This also goes back to about the 19th century, the same period in which they figured out the orbits. So, if you find accurate knowledge of the diameters of the planets in an old text, then that's quite an amazing thing. Well, it turns out that this is to be found in the Surya Siddhanta. The diameters of the planets are given within about 10% in agreement with the findings of modern astronomy. And given the round figures with which the diameters are listed, 10% is about as good as you could do. In other words, if you wanted to have more accuracy, you'd have to put in decimal places instead of using round figures. So, this is another example. So how could they have known? So the indication is that in an earlier period, there was detailed knowledge. So that's the basic point, which it's one of the points that Śrīla Prabhupāda wanted to make, as he points out in this letter. This is something that can be presented to scientists, and in fact, I've made an arrangement to present this material at a scientific conference, which is coming up at the University of Virginia in the end of May. So I've already sent in an abstract, which was accepted for presentation in this conference. So also, to present this material, basically the best way to do it is with pictures. If you just talk about numbers, that doesn't really convey the idea very clearly. But we're preparing a lot of pictures, and I'm also going to make a presentation here. We should have everything ready for that also by early in May, when the various GBC meetings and education meetings and so on will be taking place here in Alachua. So those are a few observations. The basic point that can be made is that on the one hand, the information given in the Bhagavatam about astronomy seems to be rather difficult to comprehend, or it seems as though it's something that just doesn't fit into the modern picture of things. And certainly the Bhagavatam does not describe things in the way that modern scientists would describe things within the universe. But you have to look beneath the surface a little bit, and if you do, you'll find that there's a great deal of genuine knowledge within the text of the Bhagavatam. So, if things are described in a way that does not agree with the modern approach, there are really two reasons for that. One reason is that in addition to the features that agree with modern astronomy, there are additional features to the universe which are not understood or known to modern science. The Bhagavatam is not dedicated just to giving the modern scientific picture. It describes some things that agree with modern science because, in fact, science is right about the universe in some ways. It's not that they're completely wrong about everything. And so you would expect there to be some agreement with what the Bhagavatam is saying. But then again, the Bhagavatam is describing dimensions of reality that go beyond what is understood by the scientists. They still have more progress to make. Speaking of progress, it's interesting to consider that if you went back, let's say, to the 17th century, then all the findings that I was just referring to could not have been made, because the measurements that I'm referring to hadn't been made by the astronomers at that time. So, at that point, these observations would not have been possible. So, in the future also, there may be further revelations through scientific observation which tend to help back up the picture in the Srimad Bhagavatam. So, I'll just say a little bit more about the stars, since Śrīla Prabhupada refers to the stars in this purport. In the letter, you can note that Śrīla Prabhupada says the stars may have the same composition as the sun, but they are not suns. So that's an interesting observation. The stars are understood to be luminous, self-luminous, by modern astronomers, and they determine this using what is called a spectroscope. Basically, by analyzing the light from a star or another source of light, you can get some information as to what is producing the light. And in the case of the stars, the indication is that they're very similar to the sun. They produce light in the same way that the sun does. And both the sun and the stars are similar to a hot flame. If you look at a flame with a spectroscope, you see the same basic sort of spectrum. It indicates a hot, gaseous substance. So Śrīla Prabhupada is saying that the stars may have the same composition as the sun. That's certainly what the scientists would say using their spectroscopes. But then he says, but they're not suns. So that is also, of course, perfectly possible. After all, a fire also gives out light with the same sort of spectrum, but a fire is not the sun either. It's a question of the role that the given body plays within the universe. So Śrīla Prabhupada is saying that there's one sun within the universe. Now, here in the purport he referred to reflection, but the idea that the stars could be luminous is also there. He said they may have the same composition. There's a very interesting passage in the Mahabharata describing the journey that Arjuna took to the planet of Indra. It's described that Arjuna was taken in the chariot of Indra up to Indraloka. That's when he acquired celestial weapons from Indra. So in the course of his journey, he went through the region of the stars. And the passage describes what the stars are like. It says that the stars are very large, self-luminous bodies. So that would agree with the modern astronomers. It also says that the stars are the hearts of kings who are elevated to heaven because of their pious deeds. In other words, the stars are dwelling places where kings and people of that nature are living who had performed pious deeds and were elevated to the heavenly planets. So the stars are actually dwelling places, and also they are self-luminous bodies. So it also is stated in this passage that the sun and the moon are not visible in this region of the stars. So it's interesting. This agrees with what the scientists would say also. If you ask them what would happen if you traveled into the region of the stars, they would say, well, you wouldn't be able to see the sun and the moon. The sun would just be like another little point of light. And you would see that the stars are very large, self-luminous objects, but they don't mention the kings that are living there, and so on. That's an additional feature. And indeed, it would suggest that the stars are playing a different role in the creation than the sun is. They're the dwelling places for persons who've been elevated to the heavenly regions, and so on. So that's just another observation concerning the universe. There are many things about astronomy, just to sum that up, which the astronomy as mentioned in the Vedic literature, which seem a bit hard to relate to from the modern point of view, but there are also many things which agree with the modern information. And basically, some of these things can even be presented quite readily to the modern scholars and academics. Let's see. Yeah, here it is. On the sun-like divine wonder-working chariot, the wise scion of Kuru flew joyously upward. While becoming invisible to the mortals who walk on earth, he saw wondrous airborne chariots by the thousands. No sun shone there, or moon, or fire, but they shone with a light of their own, acquired by their merits. Those lights that are seen as the stars look tiny like oil flames because of the distance, but they are very large. The Pandavas saw them bright and beautiful, burning on their own hearts, with a fire of their own. There are the perfected royal seers, the heroes cut down in war, who, having won heaven with their austerities, gather in hundreds of groups. So do thousands of Gandharvas with a glow like the suns or the fires, and of Duyakas and seers, and the hosts of Apsaras. So that's the description. I'll go to Srila Prabhupada. Any questions? Yeah?
Prabhupada wrote the letter that one sun lights up the universe. But then in Mahabharata, when you couldn't see the sun, it was like a cloudy day that lights up the heavenly region, but no one's aware that the sun's lighting it up.
Well, the only way I can reconcile those two things is to say the sun is providing light in the areas where it is needed within the universe, but apparently in this region of stars, in the heavenly regions, perhaps that light is not required. In other words, the role of the sun is it's the supplier of illumination, but these particular stars are self-luminous objects, just like at night you have lights on in your house or whatever. And that's how things are out there, where those stars are. That's the way I would read it. Yeah?
Whether you had heard or read anything about this recent thing they did, they focused the Hubble telescope from distant places, the universe for 10 days, and photographed that one photograph.
Oh, are you referring to Betelgeuse? For a long time, scientists have been trying to register the disk of a star. Of course, everyone believes that stars are round, they're disks. But to this day, no one has ever seen that. Because if you use a telescope, no matter how powerful your telescope is, and you look at a star, it looks just like what we see with our naked eye. It may look brighter through the telescope, but all you see is a little pointy glob of light. You can't resolve a disk. So they've been trying to do it, and they use long time exposures and statistical methods, because one problem is the atmosphere of the Earth is constantly shifting, and that makes the light swing back and forth, and it blurs the image. So of course their idea is the Hubble telescope is up above the atmosphere, so then they don't have that problem. But even with the Hubble telescope, you can't see a disk if you just aim that at a star. So they've been trying to use mathematical methods applied to what they get by collecting the light over a long period of time to see if they can calculate the disk from the information that the telescope provides. And I think they were reporting some success with that. This was in the case of Betelgeuse, which is said to be one of the largest stars. It's in the constellation Orion. So that's one thing that... well, I would suspect that a star probably does have a disc-like shape. Like anybody else, it's sort of the natural shape that a star would have. So one assumes that they have that shape. But then again, no one has seen it. I don't know anywhere in the Bhagavatam where it says that they don't have that shape, or that they do. I haven't run across a mention of it. But I wouldn't be surprised if they're called globes or mandalas or something like that somewhere in the Vedic literature. Yeah?
You're making the comparison between the orbits of the planets and the measurements of the Greeks.
Mm-hmm.
Now, the Greeks are all on Bhumandala, which is one plane.
Right.
Does that mean that the orbits of the sun, of the planets rather, all can be seen as being on a particular plane?
Yes, they are, in fact. They're not precisely on a plane, but they're all very close to one plane. So that's one feature of the solar system. So, yeah?
Why science has such extraordinary distances. You know, when we talk about quadrillion light years and things like that, it's we're so far off from the
Yeah. Well, one can explain how they do it. I'll just say a couple words very briefly, because that would be a whole lecture, I'm afraid. But you see, the starting point is what is called parallax, and that's a very simple thing in principle. Suppose you're moving back and forth. Well, you'll see objects in the distance move back and forth as you move. And if you measure the angle to an object in one place, then move to another place and measure the angle to that object, and then you know the baseline between the 2 points, you can calculate the distance by trigonometry. That's called triangulating, and it's what surveyors do. So they will say, okay, the Earth is going around the Sun, and we know the radius of the orbit. So after half a year, we've gone one diameter across. Now suppose we look at a star, and we measure the angle to the star, then half a year later, we measure it. Now if we get a difference in the angles, then when we knowing the baseline, we can calculate how far the star is. They'll say that for some stars they can do that. And they get distances in the order of several light years. So they'll say the closest star is 4 light years away. And they'll say with many stars, actually most stars, you can't measure any difference in the angle after half a year. And they'll say, well, the reason must be that they're so far away that you can't even measure that slight change in angle. So that means they're much more than, say, 4 to 10 light years away. So this is the starting point for their gigantic distances. And the starting point, of course, depends on the idea that it's the Earth going around the Sun rather than the Sun going around the Earth. By the way, one thing I should mention, all those correlations with orbits that I was talking about, you get that by looking at the geocentric orbits. That is, you recalculate everything so that the Earth is in the center, and then you get all these agreements. So Śrīla Prabhupāda was making a curious statement here. He was saying, the Sun is not fixed. If this is proved, then their whole scientific theory collapses. Well, it's interesting to see what collapses there, because in one sense, you can say that any point you like is at the center and everything else is going around, because it's just relative motion. But the key point concerning the movement of the Sun as opposed to the movement of the Earth has to do with how far away everything is, because that's the starting point for measuring the distances. So there's a lot more to say about that, but we'll stop there. All glories to Śrīla Prabhupada.